Okay, the next problem I'd like to look at is problem 16 on page 121. I've got that right here. An equilateral triangle is inscribed in a circle of radius r. Express the circumference c of the circle as a function of the length x of the side of the triangle. Okay, so we have a picture of an equilateral triangle and a radius of r, the circle. And so what I've done is I've redrawn this circle, and I've included the left side of the triangle, so one side is x, one side is x divided by 2, and the hypotenuse is h. And this is a right triangle, by the way. So I can use the Pythagorean theorem. X over 2 squared plus h squared equals x squared. We get x squared over 4, which we're going to subtract. So h squared is equal to 3/4 x squared. And if I take the square root of both sides, h would be 3 over root 3 over 2 times x. Okay, so root 3 over 2 times x is that distance right there. And I want to subtract r, which is the line segment from the middle of the circle to the top. So I've got another triangle. This is also a right triangle. R, x over 2, and then root 3 over 2 x minus r. So x over 2 squared plus root 3 over 2 x minus r squared equals r squared. Okay. X squared over 4 plus 3/4 x squared plus 2 times root 3 over 2 x r plus r squared equals r squared. R squareds cancel, the 2's cancel, and 1/4 x squared plus 3/4 x squared gives me x squared. I'm going to subtract, or I'm going to add root 3 xr to both sides. And so r would be, when I divide by root 3x, r is equal to x over 3. Okay, the circumference of a circle is 2 pi times the radius. And the circumference is a function of x. So 2 pi times is what x is. X over root 3, and that'd be the answer. Problem 20 is another good one. Inscribing a cylinder in a sphere. Inscribe a right circular cylinder of height h and radius r in a sphere of a fixed radius capital R. Express the volume V of the cylinder as a function of h. Okay. So I've got the circular cylinder drawn in a sphere of a radius capital R. The cylinder has a radius of little r and a height of h. So let's see, h over 2 plus r equals capital R. H over 2, that'd be h over 2 squared plus r squared equal capital R squared. I've got a right triangle. There's a Pythagorean theorem. And so solve for r squared. Capital R squared minus h squared over 4 is going to go in place of r squared, little r squared. So v of h is pi times h times r squared minus h squared over 4. R squared is some fixed constant. It doesn't change in the problem at all, since that's the radius of the circle. Okay. And the last one that I'm going to do is problem 22 on the next page here. Okay. So Metro Media Cable is asked to provide service to a customer whose house is located 2 miles from the road along which a cable is buried. The nearest connection box for the cable is located 5 miles down the road. Okay, and they have a picture for us. Part A, if the cost of installation is $500 per mile along the road and $700 per mile off the road, build a model that expresses the total cost, C, of installation as a function of the distance x in miles from the connection box to the point where the cable installation turns off the road. Find the domain of C, which is a function of x. Okay, so I've got a picture here of the house and the box, which is 5 miles down the road, and the house is 2 miles from the street. And suppose that we go y units over. Y is what we got, something we got to find, and x units down to the box. Okay, now the box is 5 miles down from the house. So wherever y is, that distance is 5 minus x. This is 5 minus x plus x would give me 5 total. Here I could use the Pythagorean theorem. So 5 minus x squared plus 2 squared equals y squared. Or 4 plus 25 minus 10x plus x squared equals y squared. Okay, 4 plus 25 is 29. Take the square root of both sides. Y is the square root of x squared plus 10x plus 29. Okay, so I've got $500 for the amount of cable that's going to be laid on the road, and then $700 for the amount of cable that's going to be laid in the grass there, x and y. So 500 times x plus 700 times y. Y is in terms of x, the square root of x squared plus minus 10x plus 29. And that's going to be the function that we're going to want in the problem. The domain of C is the set of all x such that x is between 0 and 5, including those endpoints. So it can't be any larger than 5 or any smaller than 0. Okay? C of 1 is what? 500 plus 700 times 1 minus 10 is 9 plus 29 is 20, root 20. 500 plus 700 times root 20 is 3,630.5. Okay, so that's how much it cost if I were to lay connection lay the cost that's 1 mile away from the box. Suppose we're 3 miles away from the box. Well, if we're 3 miles away from the box, 500 times 3 is 1,500 times 700 times 9 minus 30 plus 29, it gives me root 8. So 700 times root 8 it looks like it's going to be cheaper to do it that way. C of 3 rather than C of 1. So I want the box to be 3 miles and not 1 mile. Now, the next question is, what is the exact distance of the box in terms of x? To find that exact spot, I'd want to minimize the cost function. Okay, so I minimize the cost function using my calculator. And let's see here. So I've already got that function typed in. Okay. And I want to minimize the cost. Left bound. Bound, guess. 2.96, 3,479.80. Okay. So that's when C is going to be the smallest. By the way, the window that I used here, if I show you that, here's the settings for the window that I went with. Okay, so C is going to be smallest when x is approximately 2.96 miles. So not quite 3 miles. We get something that's a little bit smaller than that. Although 3 miles is very close to the answer, only a difference of 10 cents, really. The homework is on page 120. Try 1 through 25, the odds for me when you get a chance.